Today we start chapter 12. We're going to talk about angles and degree measure as the first part of today's lesson. And we are preparing for the trigonometry standards now. Trig Standard 1 is students understand the notion of an angle and how to measure it in degrees. Chapter 13, section 1, we'll talk about measuring an angle in radians. So today's objective is to use degrees to measure an angle. And the way we generate an angle is we rotate a ray. We have the initial side, and we rotate it until we have another ray called the terminal side. When that initial side, or that initial ray, starts on the positive x-axis, then we say that angle is in standard position. We get positive angles by rotating the rays counterclockwise, and we get negative angles by rotating the rays in a clockwise direction. So if here is my initial ray, and we rotate it counterclockwise, and that's the terminal side, there was my initial side, this would be an angle of positive 150 degrees approximately. Here's another angle. We're going to start with the initial side. We're going to rotate it clockwise, and this would be a negative angle then because we're rotating it clockwise, and that's approximately negative 45 degrees. For standard position angles, let me remind you the names of the quadrants. Starting here in the top right is quadrant 1, quadrant 2, quadrant 3, quadrant 4. We use Roman numerals. Here's the x and y axis. And so we're going to start with our initial side on the positive x-axis. And if we rotate counterclockwise, this is approximately a 120 degree angle with its terminal side in quadrant 2. Let's start with another x and y axis and our quadrant names. And if we start with our initial side on the positive x-axis and rotate positive again, that's approximately a 60 degree angle. When the terminal side is on the x-axis or the y-axis, we have a special name for that situation. We call that angle a quadrantal angle because it ends on either the x-axis or the y-axis, which are the lines that divide us into the quadrants 1, 2, 3, and 4. So in this situation, if we have the initial side on the positive x-axis, rotate counterclockwise, and on the negative y-axis, that's an angle of 270 degrees. And it's a quadrantal angle. Alright, we have another vocabulary word for this, and a different situation. But if we have two angles whose terminal sides are the same line, we call them coterminal angles because they are sharing that common terminal side. So here's a situation where we start with, again, standard position, our initial side on the x-axis, rotate counterclockwise 150 degrees, there's our terminal side. And if we had another situation like that, only we took a lap around the track, so we rotated counterclockwise 90, 180, 270, 360, another 90 plus past that, which is 450, and then ended up in the same position to get a 510 degree angle. That is actually the same terminal side as the 150. So we say that a 150 degree angle and a 510 degree angle are called coterminal angles. Here's another coterminal angle of the same thing. If we started with our initial side on the positive x-axis and rotate negative direction, which is clockwise, end at the same position, a negative 210 degree angle is considered a coterminal angle also with 150 and 510. And without drawing the pictures, we can find measures of coterminal angles of 150 degrees, which is our example here, by taking 150 degrees plus an integer times 360. So that represents how many times we're going to go around the circle and end. So in this case, let's write some measures of some angles coterminal with 30 degrees. So we're going to take 30 plus n, an integer, times 360. And let's put in a couple of integers like -2, -1, +1, +2 for n. If we put in -2 times 360 is -720. -720 plus 30 is -690. When we replace n with -1, that'll give us another coterminal angle of 30. So -1 plus 360 is -360. -360 plus 30 is -330. Alright, let's put in +1. 1 times 360 is 360. 360 plus 30 is 390, so that's another coterminal angle. Let's substitute in 2 for n. 2 times 360 is 720. 720 plus 30 is 750. So all of these angles are coterminal angles of a 30-degree angle. -690, -330, +390, 750. And remember, coterminal just means their terminal side lies on the same spot in the exact same position. Alright, now it's time to talk about another way of measuring angles in degrees, because 1 degree is not accurate enough. So we take that 1 degree and we divide it into 60 equal portions, each one called a minute or 60 minutes. So 1 degree is equivalent to 60 minutes. But a minute is not accurate enough, so we take that 1 minute, divide it into 60 equal portions, each one called a second. So 1 minute is equivalent to 60 seconds. Now this may sound familiar to you because it's very much like hours, minutes, and seconds. And so if we know how to keep track of time with hours and minutes and seconds, then it shouldn't be too hard to deal with degrees, minutes, and seconds because the same rules are going to apply. So remember that 1 minute, and I know that looks like the foot symbol, the single apostrophe there, but in this case that means 1 minute. That's 1/60th of a degree. And 1 second, I know that looks like the inch symbol, but we also use it for seconds, is the same as 1/60th of a minute, or is the same as 1/3600th of a degree. So with that in mind, we're going to try to convert back and forth between degrees, minutes, and seconds into decimal degrees, and then later we'll go in the other direction from decimal degrees to degrees, minutes, and seconds. So for 14 degrees, 36 minutes, 54 seconds. Here's what we're going to do in this particular approach. We're going to break that down as to 14 degrees. The 36 minutes are out of 60 minutes, so that's 36/60ths of a degree. And the 54 seconds are out of 3,600 seconds that are in a degree. So let's take our calculators and divide those out and see what we get. So the 14 degrees is there. The 36 divided by 60 is 0.6, 6/10ths of a degree. And the 54 divided by 3,600 is 0.015, or 15/1000th of a degree. If we add those together, 14 plus 0.6 plus 0.015, we get our decimal answer, 14.615 decimal degrees. So again, converting in minutes, there were 60 minutes in a degree, so 36 divided by 60. And in seconds, 54 divided by 3,600, since there are 3,600 seconds in a degree, just like there are 3,600 seconds in an hour. Alright, well, let's go in the other direction now. We're going to convert 72.568 decimal degrees and convert that to degrees, minutes, and seconds, and we're going to round our answer to the nearest second. In order to do that, let's start with the decimal portion of this number. What's to the left of the decimal we know is going to be 72 degrees, but the 0.568, if we multiply that by 60, that'll tell us how many minutes there are. When we do that, 0.568 times 60 is 34.08 minutes. So we've got 34 minutes. Now we're going to take the 0.08 and multiply that by 60 to see how many seconds there are. So 0.08 times 60 is going to give us 4.8 seconds. So far we have 72 degrees, 34 minutes, 4.8 seconds, which when we round that to the nearest second is 72 degrees, 34 minutes. The 4.8 seconds will round to 5 seconds. So again, what we did is we took the decimal portion times 60 to find out how many minutes there were, and everything left of the decimal 34 represents the minutes. We took the decimal portion left over from there, the 0.08, multiplied by 60 again to find out how many seconds, and we rounded 4.8 to 5 because it asks us to round it to the nearest second. Well, that's our look today at measuring angles in degrees and looking at how we get positive angles, negative angles, angles in standard position, how we form angles by rays, how we can convert from degrees, minutes, and seconds to decimal degrees, and decimal degrees into degrees, minutes, and seconds.